sorry, I was just having some lag. So we had 3 lightning talks in our group. The first one, Gabe Goman talked about lunar gravity and how this can highlight regions where you might be more likely to access SPA ejecta, specifically ejecta that contains more high density material or more likely to contain mantle material excavated by SPA. And yes, so basically you can look at these potential maps of potential percent of mantle concentration in different regions where you have these gravity anomalies that might highlight regions where you have higher density material in the subsurface. And then there's also craters that have excavated material from these regions. So looking at the ejecta of craters that have impacted regions of high density material could also give a mechanism to access this potential mantle material at the surface. The next lightning talk was by Dave Smith, looking at crustal density. And so Dave highlighted that regions where there's potentially higher density crust is also more likely to contain this higher density mantle material mixed in with that crust and could provide a better site for accessing potential mantle material excavated by SPA. And then the final lightning talk by Harry Elizabeth looked at potential figures of merit for accessing sites that could maximize geophysical measurements. So there's several different types of geophysical measurements: seismicity, thermal flux, electromagnetic properties, and gravitational tidal responses. And so you would want to look at sites where you could obtain a wide variety of these types of measurements to provide geophysical insight into the SPA basin and lunar evolution. So here is the list of all our participants. And yeah, so now going on to the various figures of merit. So one figure of merit was understanding the nature and distribution of mantle material in the ejecta of SPA at depth, and that would be accessible from geophysical observations from the landing site. So you want to kind of understand the broad context of this mantle material at depth within this SPA ejecta blanket. And so you would want to look for sites that are overlying buried bodies of mantle-rich ejecta, which is revealed by these short wavelength positive Bouguer anomalies. And so you can assess this by modeling the mantle fraction in various sites or by looking for sites that are near these positive Bouguer anomalies. And so here's this kind of examples, figures of this type of analysis from that Gabe Goman abstract, where you can highlight regions where you have potentially higher concentrations of mantle material. And those are also close to these positive Bouguer anomalies. Now, and so this figure of merit kind of looks at kind of subsurface, kind of just more geophysical observations at the surface you can do to characterize this material at depth. But there's a separate science goal of actually understanding the composition of the lunar mantle, and basically involves being able to sample this material. So for this metric, you want to be able to sample this material derived from this SPA ejecta blanket, exposed at the surface from excavation by smaller craters. So within that map of these regions where you expect this high density material, you can have craters that can excavate this material, and you'd want to sample the ejecta blankets of those craters to try to obtain this material that would have been excavated from these craters and that could contain this high density mantle material. Okay, and then the next science goal would be understand kind of the regional structure and thermal state of the lunar interior. So this would involve geophysical measurements such as ratio of background heat flux to surface heat flux. So local changes such as proximity to craters or PSRs can change the local surface thermal gradient. And so you would want to choose sites that are further away from those disturbances if you wanted to be able to kind of get measurements that reveal the more general lunar thermal heat flux. And then lower priority, but there was some also discussion of retroreflectors in terms of being able to get these large geophysical structures of the moon from measurements. And depending on where Artemis 3 goes, if Artemis 3 is on the far side, having a retroreflector on the near side could provide some value to that. Then another science goal was just understanding the subsurface structure and material properties of this rim of SPA. So understanding kind of this rim and ejecta area of SPA by looking at the subsurface properties. This can be done with a lot of different geophysical measurements, such as seismic measurements, gravity, electromagnetic sounding, ground penetrating radar. But the overall metric is you want to choose a region that kind of has minimal secondary overprinting. So you want to choose a region that's more characteristic of the SPA ejecta and isn't overprinted by more secondary geophysical geological processes. And then finally, there was another science goal of looking at the history of the lunar dynamo, and particularly magnetic anomalies in potential relation to impact basins, including SPA. So SPA anomalies have been suggested to be related to the formation of the SPA basin, and so better understanding those anomalies could provide insight into the formation of SPA, as well as the history of the lunar dynamo as a whole. And so you'd want to choose regions that have a closer proximity to magnetic anomalies. Now, the magnetic anomalies in the region of the South Pole aren't as strong as in other areas of the moons, for example, the Northwest SPA basin, but there still are some magnetic anomalies there. And so you could target areas that could provide some proximity to that. Another thing that we did note in terms that came out in our discussion is that the Lunar Geophysical Network has done lots of work looking at metrics for where kind of a geophysical network suite of instruments could provide the best scientific output. And so potentially for this kind of more broad metric of just understanding the subsurface structure material properties, we could look to what they have done and get some insight from that. Okay, and I can't exit this for some reason.
That's okay. Do we have any questions for this group? This is an impressive amount of work. Thank you so much. Questions for geophysics? If you use your raise hand, we'll unmute you. None? Yep, Brad, go ahead. Oh, no, you're not unmuted yet. All right, go for it, Brad.
Okay, so yeah, I put something in the Q&A, but I didn't see it show up. When we're talking about gravity data, and from the discussion you had in the group, you're seeing something at depth, and it has to be modeled. But how do you extrapolate from what is inferred from depth to the surface?
Yeah, so so the idea is that this gravity data can give you regions where you think there was material in the subsurface. And then there were kind of two different types of measurements you could do in terms of examining where you might see this SPA mantle material. One is looking at the subsurface structure. So in this, it'd be a region where it'd be above these positive gravity anomalies, so that geophysical instruments could reveal something about the subsurface nature and distribution of this material. And then if you want to find it at the surface, potentially the most likely locations would be where craters have impacted this material and then potentially excavated this denser material to the surface. And then also there's an overall kind of metric of just the bulk crustal density, where if you go to regions where there is an inferred higher crustal density, closer to the surface, then that could potentially be regions where there is more of this denser material mixed in with the surface material. Does that answer your question?
Yeah, thanks.